Hello all. In this video lecture, I'll be discussing about the conversion of a DFA to regular expression with an example. So for this, first you should refer the previous video where we have introduced what happens when we have k is equal to 0 and k is greater than 0, which is the basis and induction steps. So here we have R, I, J power k. So this is the representation for converting. This is the regular expression. R is the regular expression, I is the start state, J is the final state, and K is the number of states. So keeping this in mind, we want to convert a DFA to regular expression. Now first, let us take an example. So here, this is the start state. The state is 1. Start state is indicated with an arrow mark pointing towards the state with a start label on it. And this is the final state where you have a double circle and the state is 2. Now, this is a DFA representation. We want to find the equivalent regular expression. Now, regular expression, as I told, is of the form Rij power k. So here, if you see, this is the start state. 1 is the start state. So instead of I, I've written 1. Final state is 2. And number of state is 1, 2. Right? So 1, 2. 2 states are there. So instead of k, I've written 2. So this is the final result of the regular expression representation. So this DFA, if I can map it to this, then I can say that is the final regular expression representation. Now for that, first I have to consider k is equal to 0. Then only I will get the values for substituting all these basic values in k is equal to 1, and finally I will identify what is the value for k is equal to 2. Now Rij, you can see this is I, this is J. So here if you see, I is equal to 1 and J is equal to 1. Next here, I is equal to 1 and J is equal to 2. Here I is equal to 2, J is equal to 1. Here I is equal to 2 and J is equal to 2. So I'm going to first generate all the values for Ij, various values, keeping k as 0. Find out the values and then let me go for k is equal to 1 and finally k is equal to 2. So these are the basis values. So refer the previous video for various cases. Now first, basis case, we have for k is equal to 2, we have two basis cases. One is I is equal to j, the other one is I is not equal to j. I is equal to j means I and j both are the same states. I is not equal to j means I is a different state, j is a different state. Now here I is 1, j is 1, right? So both are the same states. Now here if you see, I is 1, j is also 1, right? So from the previous lectures, you can refer the I is equal to j case, which I have presented on the right side here. Now if you see, I is equal to j, right? So here also I is equal to j. I is 1, j is 1. Now when I and j are same, here if you see, I and j are same, which is 1, 1. Now here what is happening? B is transiting to itself, correct? B is transiting to itself. So here also here A is transiting it to itself. So the regular expression for R, I, J, where I and J is 1, 1, where K's value is 0 is epsilon plus A, because A is the input symbol here. The same situation, if you check in our given diagram, you can say 1 is the state and in the right side representation, I is the state. In our given example, 1 is the state. So here it is going to be, instead of A, we will be changing it to B. So here it is epsilon plus B. The same representation, we are only going to change what is given in our diagram. Next is R1, 2. I is 1, J is 2. So both are different states. So I'll have to take a different case. I is not equal to J, right? So I is not equal to J. Now I is not equal to J means here I have I is 1, J is 2. So when I is 1, J is 2, both are in two different states. Now let me check. I is 1, J is 2, and they are transiting with an input symbol B. So here also I is a different state, J is a different state, and they are transiting to a different state A. So here it is A. Okay. Yes, A. Next, the third one is 2 is I and J is 1. So I'm going to check if there is any transition between 2 to 1. So between 2 to 1 there is no transition, so I can simply write it as empty pi. Okay, so this is the case. Next, I is 2 and J is 2, which is a different case where my I and J are the same states. So let me take the actual condition. I is equal to J. When I is equal to J, here both are 2 and 2, right? So let me check 2 and 2. Transition between 2 and 2. So you can take this transition between 2 and 2. And I have a set of symbols A1, A2, A3 in the given template. Here if you see in the given diagram A and B. So what am I doing with that? I have to convert it to epsilon plus A1 plus A2 plus so on. So here I will be writing it as epsilon plus A plus B. Whatever symbols are there, I'm going to add a plus symbol and I have to make it. So this is when K is equal to 0. Next, let me see for K is equal to 1. So if you remember, for K is equal to 1, which is K is greater than 0, we had this equation which you can refer the previous video. So write this equation first. Okay, sorry, write this equation first. Now K is equal to 1. Wherever you have K here, you can substitute 1 and replace it to the actual equation that is required. So this is the actual equation which is required. So Rij power k, instead of k I write 1. And wherever you have k minus 1, you can substitute it with 0 because 1 minus 1 will be 0. So wherever I have k minus 1, I have written it as 0. So instead of k, I am replacing it with 1. Instead of k, I am replacing it with 1 and so on. So now the same case. So I want to find Rij. Instead of I and j, I'm going to give various values. So here I is equal to 1, j is equal to 1. Next, I is equal to 1, j is equal to 2. Here I is equal to 2 and j is equal to 1. Here I is equal to 2 and j is equal to 2. For all the various values, I'm going to find out what is the value from this expression. So first, consider for here all the k values will be 1 only. Okay, because k is equal to 1. Keeping that as the fixed value, I'm going to find the varying Rij values. So first R11. So R11 power 0. So substituting the values here, okay, in this expression. Now R11 to the power 0. Okay, here I am going to substitute R11 to the power 0 is from this table, from the previous slide, you can note it down as epsilon plus B. Okay, plus, you can separately write it, plus R, I is 1, right? So again R11 power 0, which is R11 power 0 is again epsilon plus B Then again r11 power 0 the whole star. So the same value, epsilon plus b the whole star, and then this is concatenation r11 to the power 0. So again epsilon plus b. Okay, so this is the first step. Then we will simplify it using the simplification in regular expression. So there we had some 15 equations with which you will be simplifying this. So here next r I is equal to 1, j is equal to 2. So keeping that in mind, you will have to place it here. r12 is equal to r12 power 0. So 12 power 0 is a plus here r11 to the power 0. 11 to the power 0 is epsilon plus b. Again here r11 to the power 0, which is epsilon plus b the whole star into here, if it is here it is j, right? So r12 power 0, 1 to power 0 is a. So like this we have to make it for all the values. Next r21 power 1. So r21 power 1 is, instead of I we have to substitute 2, instead of j we have to substitute 1. So 21 power 0, 21 power 0 is pi. Next plus, so here we have plus, so plus. Next I is 2, so 21 power 0, 21 power 0 is pi. Next concatenation, then r11 power 0 is epsilon plus b. So epsilon plus b this whole star, and r11 power 0, which is epsilon plus b. Next r22, so substituting here r22 power 0 is epsilon plus a plus b. Then next plus rji1, so I is 2 here, so r21 is pi, and r11, so which is epsilon plus b the whole star, and then r1j, so it is 1 2, so it is a. So now this is the expression. Next step is to simplify this expression. Okay, now these are the after direct substitution we are getting these expressions. Now we need to simplify it. So you can refer the simplification templates. Then you will find that epsilon plus b. Then if you simplify these, you will get plus b star. Now this you can simplify it to b star. Similarly here, if you take a plus, then if you simplify this, you will get b star and then a. So which can be simplified to b star a. Then this mt plus mt, this is a complete expression. So this is in concatenation with pi. So this is pi. Then this you have an expression. Okay, this is union with pi. So this is also union with pi. So you pi union with an expression with pi is pi. So here also you have an expression which is in union with pi. So you get the expression itself, epsilon plus a plus b. So this is what you get for k is equal to 1. So here you can see that rij power k. So here everywhere we have k. Next we'll see what are the values for k is equal to 2. Next is for k is equal to 2. So you will have to keep all the possibilities for I and j. So first is I is equal to 1 and I is equal to 1 and then j is equal to 1. This is I is equal to 1 and j is equal to 2. Then I is equal to 2 and j is equal to 1. Finally, I is equal to 2 and j is equal to 2. So substitute it in the main equation uh, where all the k's are 2 and k minus 1 is 1. So when you substitute, you get this above equation. So you will have to find the values here. So first, Rij. So I and j are 1. So here you get R11. So when it is R11, you get epsilon plus b, um, epsilon plus b star, which is b star. So you will write b star, okay, plus I is 1 here. So R12, which is b star a, okay, b star a. Then it's concatenation. R22 is your epsilon plus a plus b, the whole star, and then R21 is empty. So which will be equated to, because it is pi, which will be equated to b star. Next, if you take 1, 2, I is 1 and j is 2. So when it is 1, 2, you get b star a, plus again it is 1, 2. So again it is b star a. And then concatenation with the 2, 2. So which is epsilon plus a plus b, the whole star. Then 2, 2 again. So it is epsilon plus a plus b. Okay. So here it is 2, 1. So substituting 2, 1, you get pi plus, then here it is 2, 2. So 2, 2 means epsilon plus a plus b. Then again here you have 2, 2. So epsilon plus a plus b, the whole star. Then you have 2, 1. 2, 1 is empty. So this is empty plus empty, which will be empty, pi. Then here it is 2, 2, right? So 2, 2 here means it is epsilon plus a plus b, plus again here you have 2, 2, again the same epsilon plus a plus b. Then again 2, 2. So again epsilon plus a plus b, the whole star. Again 2, 2. Again it is epsilon plus a plus b. So if you simplify this, you will get this is regular expression plus the same regular expression. Then you have epsilon plus a plus b, the whole star, with epsilon plus b. So this is going to be b star a into a plus b, the whole star. Then this is, you have an expression with, this is union, and then okay, this, if you simplify it, you will get a plus b, the whole star. Okay, this part alone, you will get a plus b, the whole star. So when you do the union operation, you will get a plus b, the whole star. So for our question, the final answer is R12 to the power 2. So for R12 to the power 2, this is the expression. So for the given DFA that was given in the question, this is the equivalent regular expression. So this is how we need to find the answer. Thank you.